Have you ever typed a simple question into ChatGPT, like asking for the capital of India, and wondered how it actually reads your sentence? The machine isn't reading those human words at all. It actually processes a continuous stream of pure numbers. To bridge the gap between our language and its math, the AI chops your text into tiny numerical pieces. We call these pieces tokens. Watch how this diagram slices the sentence, "I love India." Breaking it down by individual characters, including spaces, gives us 12 separate pieces. But reading it normally, we see 3 standard words: I, love, and India. Now watch how the AI tokenizes it. It slices into 3 pieces, but notice the empty space is glued right onto the word. To an AI, a blank space is meaningful data. Tokens are flexible chunks of text that serve as the primary medium for everything the AI processes. You might be wondering, why make it so complicated? Why doesn't the AI simply memorize a massive dictionary of whole words? Think about every word in every language, plus slang terms and spelling mistakes. Storing all of that would require a database so large and expensive it would be nearly impossible to maintain. Instead, the AI uses a clever solution. It treats language like a box of Lego blocks. Rather than memorizing the entire long word, the AI snaps unbelievable apart into 3 reusable blocks: un, believe, and able. When you type a made-up word like hyperdigitalization, it just snaps a hyperblock onto the existing digit and alization blocks. By using this modular system, the AI can process an infinite variety of human language using only a finite set of building blocks. Before the AI can even begin to think about your prompt, your text has to travel down a digital assembly line. We call this process tokenization. The first step chops your text into chunks. A scanner stamps each chunk with a unique ID number, turning hello into 1234. Finally, that ID floats off the belt and plots itself onto a massive grid, acting like a GPS location for ideas. There is a catch to this assembly line. Not all languages are processed with the same efficiency. English words are heavily represented in AI training, so they usually require very few tokens. Look closely at this photograph of traditional Chinese text. Because of how the models are built, a single Chinese character often maps neatly to a single token. Meanwhile, a word in Hindi might be broken into 4 or 5 separate pieces. Because of this imbalance, your chosen language directly dictates how hard the AI's mathematical engine must work to process your request. If you have ever had a long, ongoing chat with an AI, you have probably noticed a frustrating moment where it completely forgets something you said earlier. This happens because of a hard limit called the context window. It is the exact number of tokens the AI can hold in its active memory at any given time. Watch this transparent jar. As a conversation goes on, it slowly fills with colorful token blocks. Every model has a cap, maybe 16,000 tokens. Once completely full, squeezing new words in at the top pushes the oldest blocks out the bottom. This means AI amnesia is not a software glitch. It is a mathematical certainty caused simply by running out of token space. Beyond memory, these tokens function as the fundamental currency of the AI industry. When you look at the pricing sheets for developers, you will see rates like $1.70 per 1 million tokens. Tech companies are literally billing based on how many digital Lego blocks their servers process. When everyday users pay for a premium subscription, like Plus or Pro, they aren't necessarily buying a smarter AI. They are mostly paying for a larger memory jar, allowing for a bigger context window. Every time you hit enter, you are launching thousands of tiny mathematical blocks through a vast network of servers. Your next prompt carries the invisible weight of thousands of these tiny mathematical blocks. This is the science of how machines actually hear us.